In this video, we are going to go through some of the details on how to make a graph that has two lines using Microsoft Excel 2013. So the first thing I'm going to do is enter my data. This involves two cars, and I'm going to be measuring the time it takes to cover certain distances by these cars. So I have car 1 and the time in seconds. Make sure I have my units there in my data table. One thing you can do to extend the columns of a data table by the longest, to fit in the longest typed in thing, is to go to the border and click on it, double click on it, and it will extend it so that everything fits. So you'll see me do this right here. Double click there, and now it all fits. And I'm just entering in my times here. I'm just adding some fictional data to use as a tool to show you how to graph. I'm going to insert another row so that I can enter a title in, merge these, and I have my distance versus time. So this is just going to be a little title for my data table. Now what you do when you create a data table in Microsoft Excel is you want to insert a scatter plot. So you're going to go to the graph section and you want to insert an XY scatter plot. Most of the time in science you'll be using a scatter plot. Only very few times a pie graph or a bar graph or even a line graph will be used. Scatter plots show trends and they allow for scientists to make predictions about the data. So I have this rectangular white place where I'm going to be building my graph, and it's kind of a blank slate at this point, which is good because Excel tries to graph for you, and a lot of times they don't know exactly what it is you want on your X or Y axes, so it's not the greatest at graphing and being predictive. So I'm going to show you how to tell it what we want in our graph. This is not the, okay, so we're going to right click on this and we want to select the data. You can select the chart data range by clicking on that red arrow and highlighting all of your numbers. Now sometimes this works. In this situation it's not going to plot the right things on the right axes, so I'm going to remove these two lines that they tried to predict for us by hitting the remove button twice. So I'm removing all the data and I'm going to add my own data. So the first line of information that I'm going to add is for car 1. Click on the red arrow and I'm going to highlight my x-axis first, and then I'm going to highlight all the information I want on my y-axis. Notice I'm not highlighting the title of this, I'm just highlighting the numbers. So then I hit OK. Now I'm going to add my second line. Each line is called a series in Excel. I'm going to name this car 2, highlight my x-axis, and then highlight all the numbers in the y-axis or the y points. Hit OK, and there we have the two graphs, or the two lines I should say, on my graph. Now I'm going to show you all the intricacies of adding a trend line. We're going to add a linear trend line, even though this looks like it may be a little curved and I would maybe want to add a logarithmic line or something. I right clicked on one of the dots and I'm going to add trend line. And for the purposes of this demonstration, my trend line is going to be linear. Like I said, I would probably choose a more logarithmic line for this particular graph just because that's what it looks like the dots are doing. But we're going to choose a linear one just so that I can show you how to do the slope and best fit line and all that. So we have that line. I'm going to try to lower this so you can see everything. I want to set my intercept. And what that means is that's where the line, the y-intercept, that's where the line will cross the y-axis. And I need to think about what makes sense in this situation. I'm going to think about the data. So I have a car, and at 0 seconds it would have traveled 0 meters. So this makes sense to set the intercept at 0. Sometimes it won't make sense to set it at 0. I'm going to display the equation on the chart, and I could also display the r² value, but I'm not going to in this situation. That value indicates how good your data is how close it is to the line. Here I'm going to right click and add a trend line. I'm going to do the same thing. set my intercept at 0, and you'll see when I do that the line changes place, so that best fit line changes locations a little bit. Now you can see the both equations and both slopes of those lines. I'm going to go over here and change the axis titles to a more appropriate title. My y-axis is distance, and my x-axis is time in seconds. Make sure you include units. And the reason I had distance on my y-axis and time on my x-axis is because I want the slope to be distance over time. Generally, slope means something. I'm adding a chart title here. And in this situation, slope means the distance over the time, or the average distance over the time. And you know that distance over time is speed. So if I look at the slopes of these, the faster one has a greater slope or a greater average speed. I'm not going to include data labels or error bars in this graph, but you can if you want. I'm going to add the grid lines, and of course I want a legend. But you'll see when you insert a legend in your graph, it kind of squishes the graph over a little bit. That's okay. You can always change the size of your graph so that you can see the data points a little bit better. So here we have a graph, and I'm going to right-click on this graph and copy it, because most likely you will be putting a graph like this in a lab report or something. And here we have Microsoft Word, and I'm going to right-click and I'm going to paste this into a Microsoft Word document. So I could insert this into a lab report or some sort of document that I would be turning in to show that I did this experiment and these were my results, or the summary of my results.